Okay, quick video today just on how we report temperature and how we talk about and discuss temperature, as it's going to be important to be able to do this for our part 2 of lab number 3. Let's first talk about measuring energy and why we can refer to a temperature reading as just a simple measurement of the energy a particular substance has. We define temperature as just a measure of the average kinetic energy of the particles in the substance. This term right here, kinetic energy, I do teach this to the freshmen. I don't know if you all got it, but kinetic energy actually equals 1/2 times the mass of an object times its velocity squared. You're never going to have to work on this equation for me in this class. All I want you to notice is that kinetic energy depends on two things: speed of the molecule, mass of the molecule. Now, I think we'd all agree that the mass of particles is pretty tiny. Their speed, on the other hand, is not. It's pretty fast. And if we take a whole bunch of particles, like there are in your room right now, or wherever you are listening to this video, you eventually get quite a bit of this stuff, kinetic energy. And it's nice to be able to measure that particular kinetic energy. And that's what a thermometer does. So here we go. Here's my best drawing of a thermometer. Yeah, boy. Awesome. And obviously inside of that thermometer there is a red liquid, because we don't use mercury anymore because it turns you insane. Alright, red liquid. There it is. And every once in a while, or like always, that thermometer is placed into a room, and there are molecules throughout the room. Okay, there we go. Now, if those molecules are moving slowly, little arrows, little arrows, little arrows, then when they hit the thermometer with their little arrows, they do not transfer a lot of energy. Because if they're moving slowly, then V is small, so they have a little bit of kinetic energy, not a whole lot. And when they run into that thermometer, they don't run into that thermometer with a whole lot of force. It's like if you were talking on your phone and you weren't paying attention to where you were going, and you were just walking down the street and you walked into a light post. Would you transfer energy to the light post? Yes, but not too much. Okay? On the other hand, let's say, for instance, that we take our thermometer and we place it into a warmer room. Okay, same type of particles, right? Same amount of particles relatively if it's the same size room, but now this time those particles are moving much faster. Now, instead of walking down the street, it's like you are jogging and a bad song comes on your playlist and you look down to change it and you run into a garbage truck. You are going to transfer a lot of energy to that garbage truck. The garbage truck is not really going to care, although you are going to also feel the impact because the garbage truck transfers energy to you. That's the law of conservation of momentum. But let's not talk about garbage trucks here. Let's talk about thermometers. So these little particles now have slammed into the thermometer and they've transferred energy to said thermometer. So what happens? Well, that red liquid inside that thermometer, if it gets hot, just like we have seen with other things, it expands and it rises. And we saw this with the expansion demo, and so that's how the thermometer works, okay? Which you know, but now you know that temperature is actually a measure of kinetic energy. That's the important point. Now, it's important to understand again that this is different from heat. Again, we talked about this before. Heat is the total amount of energy in a substance. Now, how do we report temperature? We can do so in a couple of different ways. We know that the boiling point of water, I say boiling point of water, that's important because not all things boil at 100 degrees Celsius. The boiling point of water is 100 degrees Celsius or 212 degrees Fahrenheit. So those are two numbers we need to be familiar with. The freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit. Room temperature, room temp, for us is about 68 degrees Fahrenheit, or between 19 and 20 degrees Celsius. Another important number to kind of keep in the back of your head. All right. Now we are one of 3 countries, Libya and some other small Middle Eastern country, that uses degree Fahrenheit. When you travel, and I hope you all get a chance to travel at some time in your life, make sure you know what degrees Celsius means, because that's what you'll be reading the temperature in when you look at a bank sign or whatever it is you're looking at the temperature at. If you're unsure about how to convert in your head degrees Fahrenheit to degrees Celsius, there's always a handy-dandy mathematical equation that can do it for you, and it is this: degrees Celsius equals degrees Fahrenheit minus 32 times 5/9. Now, if you are taking a test, I will never ask you to memorize that equation, because that's foolish. You could always look that up. If I ever need you to do that particular conversion, you will be given this equation. This is kind of an interesting question. So if temperature is the measure of the average kinetic energy of a molecule, well, and kinetic energy depends on speed, well, what happens if the molecules stop moving? Well, in fact, this would be called something like absolute zero. There would be no kinetic energy, so there would be no energy to be transferred to the thermometer. My goodness, what would happen? Well, first of all, this can't happen. If you want to know why, see me, we can discuss it. Just trust me. Actually, we'll figure this out, I think, in part 2 of the lab. But second of all, if it were to be able to happen, which I guess it can't, the thing would have to get down to negative 273 degrees Celsius, which is mind-blowingly low, okay? We call this temperature 0 Kelvin. Kelvin? Yeah, that's a third temperature scale. Kelvin. That's absolute temperature. So that means that 0 is stopped motion, and anything higher than 0 is going to be meaning that the molecules are moving. The higher that number gets, the faster they're moving. So we use actually the Kelvin temperature scale a lot in chemistry class. And it's important to know that if you are going to report a number in Kelvin, all you do is take the Celsius temperature and you add 273. So for instance, if it were 20 degrees in my room right now, which it surely is not, I'm freezing in here, but if it were, I would add that to 273, and I would say, oh, it's 293 Kelvin in my room. Notice there's no degree symbol with Kelvin, only with Celsius and Fahrenheit. There's no degree symbol because it is, again, an absolute scale. Whew. All right, 7 minutes, 20 seconds, not bad. Have a great weekend, everybody.